So these are the contents that we will discuss one by one. So first coming to the topic Enso. What do you mean by Enso? We break the term. En stands for El Nino and SO stands for Southern Oscillation. So mostly this phenomena occur in the southern hemisphere. That's why it is Southern Oscillation term is used. So the term oscillation if we take it to the mind. So something that oscillates back and forth or move from one place to another. So here it is nothing, just the ocean temperature that we are talking about. So next question that will arise in our mind, which ocean we are talking about. Simple, is the largest one, is the Pacific Ocean because it's wide, width and large expansion in the southern hemisphere. So you can see the Pacific Ocean is the pool of water that is present in the eastern side of the American continent and the western side of the Asian and Australian continent. So it is mostly because of the irregular periodic variation in the winds and sea surface temperatures that occur over the tropical eastern Pacific Ocean. So to understand how this phenomenon occurs from this flow chart, we need to divide El Nino into three phases. First one is the neutral phase, second one is the La Nina, that is also known as Enso cool phase, and El Nino, that is also known as Enso warm phase. So neutral phase. So first of all, I want to say that there is nothing neutral when it comes to nature phenomena because nature has its own ongoing cycle and that has never been stopped. So, but for our own convenience, we have set a base level so that we can compare what things can go upon by considering the normal condition. So you can see the normal condition as the Pacific Ocean is right below the equator. So as we know that at the equatorial region, the sun rays are intense and receives large amount of sun rays over all the year. So here in this condition, the central Pacific Ocean gets warmer. And let's begin the trade winds. The trade winds are simply the winds that go from the east side to the western side in the tropical regions, somewhat called as the tropical easterlies. So in this case, the stronger trade winds, they just push the waters from the eastern side of the Pacific Ocean towards the warmer side, that is the western side of the Pacific Ocean. And this area, as you can see, there is mostly you can say a landlocked pool type. So it's create a thick pool of water, a very warm Pacific pool is also known as. So because of this WPP is created and because of this warmer region, the air of this region will rise and follow the upper atmosphere and then it forms the clouds and condensation occurs. But we know that up to a limit, that is after drop of the atmosphere, it's colder. So when the warm air mass meets the colder air mass, it loses all its moisture content and becomes dry. The dry air mass then travels eastern side and sinks down at the Peruvian and Equator coastal region. So this is a continuous manner and this flow creates a closed loop, a regrouping pattern as you can see in the equatorial side of the Pacific Ocean. So central side of the Pacific Ocean mostly, and this is known as Pacific water circulation named after Sir Gilbert T. Walker. So basically, this type of circulation is caused by the differences in specific heat between the land and the water. Coming to the next phase, La Nina, there is nothing different from La Nina and neutral phase. La Nina is simply the intensified version of the neutral phase. La Nina simply means a little girl in Spanish, also sometimes called as El Paeso, and El Nino cold phase. As here is written, same things as in a normal year, but those things become even stronger, the more and more intensified. Cold Peru current, stronger trade winds, strong warm Pacific cold that we will discuss in this diagram. As you can see, the trade winds are even more stronger as in the case of neutral phase. So it will push all the water from this shoal line away to the western side of the Pacific Ocean, and there a void space is created. And to fill up that void space, the cold nutrient-rich water wells up to the surface, and oxygen is always associated with highly productive zone. That's why in the Peru and Equator region, the coastal fishermen gives a push because they are mostly rely upon the fishing industry for their productivity. And you know that the thermocline, as here the warm water accumulates, there will be a high amount of precipitation and convective thunderstorms that we will see one by one. And the thermocline, as the warm water gathers here, the air molecules, so the water sinks down and the thermocline goes down at the warmer region and heightens up at the eastern side of the Pacific Ocean. So this is the pictures. You can see everything is same, but here the precipitation amount is very high because the trade winds are even stronger as in case of the normal year. So these are some of the effects of La Nina, as we have already discussed. There will be heavy monsoons in India, Southeast Asia. We will separately discuss about the Indian monsoon impact. but there will be increased rainfall in the Southeast Asian side, catastrophic flood because of high amount of precipitation in the Australian region, and as the central and eastern Pacific side will get less amount of precipitation, so the condition will be much and much drier, and because lack of such precipitation gives rise to winter in southern United States. So the third phase, or the last one, that is El Nino, or you can simply say it is known as the one phase of Enso. The other names are the little boy of Christ and in Spanish. So originally it was recognized by the fishermen of the south coast of America in the 1600s with the appearance of usually one water in the Pacific Ocean. It is also called as a quasi-periodic event. It means that we know that it occurs up to a 3 to 4 spiral years of life, but its periodicity is not fixed. It means it can usually last for 9 months, 12 months, or even to 18 to 24 months. That's not fixed. But as we have already discussed that in the neutral case, the trade winds, neutral and La Nina case, the trade winds plays a major role in pushing the ocean currents from eastern side to the western side of the Pacific Ocean. But here there are certain few months in a year where the trade winds get weakened. And because the trade wind gets weakened, so the ocean current that gives a push from the eastern side to the western side, they will become weak. So that is a condition when the equatorial counter current will plays a role. So the equatorial counter current will act, and what happens? The warm oceanic pull that gathers at the western side of the Pacific Ocean will start moving toward the central and eastern Pacific region, and accordingly the convective thunderstorms and high amount of precipitation will be there at the Peru and Ecuador coast, and it will give a disruption in the fisheries industry at the Peru and Ecuador region, and at the western side of the Pacific Ocean in Australia, Indonesia and New Guinea side there will be drought type conditions, just opposite to the case of La Nina. And simply the water circulation cycle, you can see the arrow direction is reversed, so you can simply call it reversal circulation or anti-water circulation. So the large looping pattern that we have already seen in the La Nina and normal conditions, so these conditions will get reversed. So in case of El Nino worldwide, there will be just opposite cases as in case of the La Nina and normal conditions. There will be wetter winter in Southeast USA, drought in Australia and Indonesia, and flood in South America, that areas that were typically dry. So this diagram basically shows us how due to Enso events the whole climate of the world get affected. So you can see there will be severe droughts and flood-like condition in the Australian region, and in the Galapagos Island there will be coral bleaching effect, and some areas there will be forest fires and tropical storms will be also created in the Tahiti region. So this is a multi-height index graph. This shows that how the El Nino occurs. So the value here you can see the value is greater than 0, or the red areas that you are seeing here. So it represents the Enso warm phase El Nino, and the value is lesser than 0, the blue areas, and you can see here this represents the La Nina phase or Enso cool phase. So the value that will be much greater than 0 will indicate a much greater impact of El Nino at that particular region. So here in this graph, around 1982 to 1983 and 1997 to 1988, in these 2 to 4 years, we have impacted or recorded major 2 El Nino events. So impacts of El Nino and La Nina monsoon rainfall in India, as we have already discussed in the El Nino and La Nina event. In the La Nina event, the tropical easterlies or the trade winds are such strong that it pushes all the ocean currents towards the Asian side at this side. So this region will be low pressure region will be created in this region, and because of the enhanced effect of the trade winds, the region will carry a lot of moisture and enhance the monsoon effect on the Indian dipole. But in the El Nino case, the trade winds get disrupted. There will be anti-water circulation, and that's why the westerlies will come into play. So that's why what happened, like will not get a push, in fact, and the moisture content will be reduced, and everything will get reversed. So there will be less amount of moisture, and precipitation rate will be lesser than the normal on the Indian side. So it is known for the pronounced effect on the Strait of Southwest monsoon in India, because the cross-like conditions are received in the El Nino years, and particularly good monsoon strength over India in the La Nina years. So these are some of the prediction tools, like some computer models and statistical and numerical based methods are there. Some ocean and atmosphere measuring devices, for example, drifting biomes and satellites. Some agencies are involved that monitor these Enso events globally, that is IMD, your Indian Meteorological Department, and NOAA, National Oceanic and Atmospheric Administration. So, in the end, I would like to say that it is a major driver of global climate variability. We need to understand all of its stages very particularly because it is crucial for mitigating our early human disasters. So, predicting and monitoring these events is must for our side, as we are our country is first agriculture dominant country, and most of our farmers in rural areas are dependent or rely upon the monsoon dependent crops. So any kind of deviation or fluctuation in these weathers can affect and lead to economic crisis. So these are very much essential for climate resilience. So that's about the today's topic.